Hi, Madam Tan here again. Welcome to my class. Hello everybody, Madam Tan here. Okay, so before we continue with the next subtopic, let us look at what is meant by deceleration. Okay, in a simple way, Madam will tell you that magnitude of velocity decreases for deceleration. Okay, idea roughly is like that, but I want to tell you a special case. For example, what you are given here, VT graph. Okay, the shape of the graph given a lengthened line like that, for example. Okay, so here the question is, I want you to identify, for this case, the object is actually travel with increasing v or decreasing v. Okay, we want to emphasize, we want to determine. Okay, for this case, if you are given such graph, this object is actually increasing v or decreasing v. So let's look at this case together. Okay, so you will find that at t equals to 0, the value of v -5, and finally the value of v 0. Okay, so you should know what is meant by the sign in front of a vector quantity. Velocity is actually vector quantity, right? Okay, means the sign convention in front of this actually means direction only. Direction. So in order to determine whether an object increasing v or decreasing v, we just look at the value of v from 5 to 0 decrease, right? From 5 is actually decreases to 0, or in BM nilai v dari nombor 5 negatif hanya menunjukkan direction, so we just want to know the magnitude. Don't bother the direction. From negative is actually decreases to 0. Decrease means decreasing v here. Okay, so answer for this case will be like this. Never mind, we will look more on such question or relate with the concept in our tutorial class maybe. Okay, so let us continue with the next one. Okay, about motion. So for information, motion can be divided into 1 dimension and 2 dimensions. Okay, today we just focus on this first. Okay, so we have already learned these two terms before, right? I will tell you, you are familiar with uniform accelerated motion. Why I say so? You still remember that 4 important equation of motion, which is this one: v equals to u plus at, s equals to u plus half at squared. Another one will be this. Do you remember? Okay, if you don't remember, now you should recall that knowledge already. Okay, so you should know these 4 equations that you usually use are actually uniform acceleration. Means motion that you solved before in SPM, the motion given are actually the value of A has the same value. Means when you solve that part of the motion, the value of A usually maintain the same value and same direction. For example, 5 meter per second square on the part. Okay, so you should know what I mean by this. What I mean by uniform acceleration. Okay, so for Madam, in order to solve this, okay, you should know some trick lah. Okay, some trick means actually means this is the way Madam always taught my student. Okay, let's see. Okay, so in order to solve question regarding such motion, I will always ask my student list down what we call, because for information, in these 4 equations, there are 5 parameters that's important. Which is, what is that? I always tell my student to remember what is it called, SUVAT. SUVAT, S-U-V-A-T, SUVAT. Okay, so you see it? You see, we have displacement here. We have velocity here. We have acceleration here. Sound familiar, right? Because just now, I already asked you for the graph. You always remember such arrangement, which is start with displacement, velocity, and acceleration. And remember, these 4 quantities are vector quantity. So the only scalar quantity in motion is actually time. So we have SUVT here. So remember, for vector quantity, sign convention important. Remember, vector quantity has magnitude and direction. So sign convention, which is mean by this one. Senang je kalau Madam sebenarnya kalau kata sign convention ni, automatically you remember the coordinate axis, which is outwards or to the right positive. Ini make sense kan? Sebab kalau dalam mathematics, axis dekat sini memang sentiasa ada nilai positif kan? Axis to the right always have the positive value here, right? And then here automatically negative. So here also the same. We always need to know the direction for those things here. Kalau pergi kanan, kita letak positif di bawah. Ya. Kalau saya dapati ini dia pergi ke arah kiri contohnya, you should put a negative sign for it. For example, okay. So you always list down those questions here, those value here. Then from here, you can apply whatever we want. Alright. So for this part, Madam stop here first. Not stop, but I want to stop for this case, and Madam want to tell you more about this. What is mean by uniform velocity? Okay, so as I told you before, see, okay, uniform velocity. Saya boleh bagi tahu kalau you jumpa keyword begini kan, automatically key point dia, you kena tahu bahawa A for this case always 0. Why? We look at the most simple equation. For example, I take this. Okay, most simple equation. Actually, this equation, if I rearrange kan, kita cuba tengok equation ni. If I manipulate or rearrange this equation, what do I get? I get this. If I want A, so you will get something you are much more familiar in SPM. Okay, familiar. Okay, and what is mean by uniform velocity? Uniform V means that the magnitude and the direction always maintain the same, right? Always maintain the same. Kalau nilai sama, contohnya kalau ini 5, ini pun 5 tolak 5, kosong kan? Kosong bahagi dengan any value, kosong divide by any value, you get always 0. So this key point ni penting. This key point, you always when you solve question regarding uniform velocity, for example, in that question, for example, we try to apply this. They ask you to find displacement. Okay, so for the case uniform velocity, remember, we also use that big 4 equation. But you should remember A always 0. So you see, where has the term A here? Here. Kalau A kosong, apa yang kita dapat? You always get this. This one, are you familiar with that? Do you familiar? Contohnya kalau saya nak U, maka saya pindahkan T ke sebelah sini. What do you get? What do you get here? You akan dapat satu equation yang you sangat suka, yang you selalu buat, iaitu ini velocity kan, ini initial velocity kan. Bagi uniform velocity, initial sebenarnya sama dengan final kan. Can you see this familiar equation now? But when can I use this? You should know when the question is about uniform velocity case. Okay, so I think for this part, that's all. Okay, so see you in next video.